This brings us to price elasticity of demand. The law of demand tells us, what we learned from the law of demand, that there is a negative correlation between price and quantity. That if the price goes up, the quantity will go down, and if the price goes down, the quantity will go up. That's great. That's all well and good. It does, however, beg the question, by how much? How much of a price change is going to lead to how much of a quantity change? Is the price change going to lead to a very tiny quantity change, or is the tiny price change going to lead to a very large quantity change? The law of demand says nothing of this. That's what price elasticity of demand is for, okay? The price elasticity of demand is going to tell us, given a certain percentage change in the price, how much of a percentage change in demand are we going to get, okay? If it is less than 1, if the percentage change in price is greater than the percentage change in quantity, then we call that product inelastic, okay? If the percentage change in price is less than the percentage change in quantity, then this number will be greater than 1. We call that elastic, okay? And we'll deal with what determines the elasticity of a product. But when we start to think of elasticity, one of the primary things is the fungibility of it, okay? So when you think of something like gasoline or addictive substances, those are highly inelastic products. A price change is not going to affect the quantity demanded that much. Whereas when you deal with something that is relatively common, okay, that is, like, for example, in primary industries, agricultural products, they have massive elasticity, okay? Now, and we'll deal with that as we go along here, as we walk our way through this, and we want to walk slowly through this, because we're going to learn how to actually calculate the elasticity of products given different areas on the demand line. When we deal with the calculation of the elasticity between any two price points, okay, along the line, we bump into a problem pretty quickly, and this is how we settle it. We use the midpoint between any 2 points on the line. Because, so for example here, if you look at this, if you do it straight, okay, without the midpoint, when you calculate the price change from $2 to $4, okay, that's a $2 price increase. That's 100% of the original value. You're increasing it by $2. With me so far? Okay. But if you go the same price change of $2, dropping from $4 to $2, you end up with a 50% price change. So which is it? Is it a 100% price change, or is it a 50% price change? Well, the way that we work this out in calculation is you take the midpoint between those 2 points, okay, between those 2 price points, which is $3. The midway between $2 and $4 and $2 is the same thing. It's $3. Okay, so you take that, and that's how you calculate it. And so using the midpoint that way, you end up with a $2 price change over $3. All right, which is 2/3. There is something called, what we call it in economics is the total revenue test, okay? And it has to do with the effect of price changes on total revenue. And we'll introduce this now, okay? Revenue is price times quantity. It's the price you get, it's the amount of money you have coming in per unit times the total number of units you sell. If you sell it for $1 and you sell 100 units, you get a revenue of $100. If you sell it for $2 and you sell 10 units, you get a revenue of $20. Okay, simple enough. If the elasticity is less than 1, then a price increase will lead to a revenue increase. Price decrease, a revenue. There is a positive correlation between price and revenue. Now, the reason that this is the case, if you think about how it's calculated, percentage change in quantity over the percentage change in price. Therefore, if it's less than 1, the percentage change in price is greater than the percentage change in quantity. So the increase in price which will in fact lead to a diminished demand, the increase in price will be more than sufficient to compensate for the diminution in demand. The price decrease, okay, will be larger than the quantity decrease, and therefore you'll lose revenue on the other end of it. Now, if the elasticity is greater than 1, that means your change in quantity is greater than your change in price as a percentage, which means that the price increase, which is bringing in more money per unit, is going to be negated by the fact that you're selling fewer units, because this is going to be greater than this. And so you'll end up with a revenue decrease, okay? And vice versa. It's a negative correlation. If the elasticity happens to be exactly 1, such that the price change is the same as the quantity change as a percentage, then there will be no effect on revenue. It will be even, okay? This has tremendous implications, okay? Because if we're, and we'll deal with the tax implications of it, what this means for government taxes, okay? But we can deal with it as an entrepreneur as well. That means if I'm in an elastic market, if I'm in an elastic point on my demand curve, okay, if I raise prices, okay, to try to make more money, which is the go-to, that's the intuitive thing. If I want to make more money, I have to raise my price. Well, that's actually going to have a counterproductive conclusion. My revenue is actually going to drop. I have to know where on my demand curve I am, okay? Am I at an inelastic point of my demand curve? Or am I in an elastic point? If I'm in an inelastic point, then I want to raise my price because that'll create a revenue increase. If I'm at an elastic point, okay, then I want to drop my price. This is something, I'll give you just a quick example of this. This is something the United States Post Office didn't understand. They still don't really understand it, but they've compensated for it a little bit. The Post Office used to have monopolistic control, okay, of daily mail delivery, okay? And so over time, they ratcheted up their price and were making more money and were profitable. But especially with the advent of the internet and so many different email services, they lost their monopolistic control over that. Well, as a result, their revenue dropped. Their solution to this was to actually jack up their rates, to increase their price. And what they found was that they actually went deeper in debt. They actually got less revenue, not more, okay? Which is why they finally adopted this solution of the forever stamp, where they're not increasing their rates at all. What they've done, what the other thing they tried to do is they tried to litigate this. The post office went to federal court, and tried to get an injunction passed. What they're trying to do is they're trying to force people, they're trying to force email providers like Hotmail or like Gmail or any of those to charge per email the same as you would charge sending a letter, okay? They've been completely unsuccessful on that. Okay, so that's, and so the other thing it does for us as economic analysts is it allows us to, at a glance, if we can just look at the revenue, we can determine the general elasticity, whether it's elastic or inelastic, okay, whether it's greater than or less than 1, just by looking at its revenue between 2 points on a line, okay? If a price increase leads to a revenue decrease, then you know that it's elastic, that the elasticity is greater than 1. If the price increase leads to a revenue increase, then you know the elasticity is less than 1. And I have an example of that in just a minute here. First, we'll deal with the calculation of elasticity itself. And I have a very simple example here, okay? Let's just take an example. Let's take the elasticity between 2 price points. This is our very famous, I suppose famous now, fish sandwich example. And let's just take the elasticity between any 2 points on this line. Let's take it between $6 and $8, okay? First of all, the percentage change in price. This is our denominator. We always take the absolute value. There is no such thing as negative elasticity. The minimum it can be is 0, okay? And that would be if there's no change in quantity whatsoever. which actually can't happen. So actually you can't have a zero. You can't have no change in quantity, because what the law of demand tells us is if you change the price, quantity will change. No question about it. That's the law. Okay, that's the law of demand. So you can't have a zero. The values are going to range anywhere from just above zero to potentially infinite. Okay, we really get into some higher order math when we deal with that level. We don't deal with that. Okay, so there will be a quantity change if there's a price change. So we always take the absolute value. We can't have a negative number. There is no such thing. So you take the absolute value. So you take the change from $6 to $8, which is $2, and then take the midpoint between them. The midpoint between $6 and $8 is $7. Okay, so 2 over 7, 2/7. Okay, now for the percentage change in quantity, that is concurrent, that is antecedent to the price change. For $6, the demand is 180 units. For $8, the demand is 120 units. If we move between 6 and 8, we move between 180 and 120. Well, that's a 60 unit change. We take the midpoint of that, of 180 and 120, and that's 150. And so you end up with 60 over 50, over 150. Well, that's 2/5. Okay. Hence, the overall elasticity is 2/5 divided by 2/7, which is 7/5. And yet you can. Okay, you could take this, if you set it up properly, you could take this and put it into your calculator. Your cell phone's calculator is more than capable of doing this. And you'll end up with a decimal figure, and that's, people like decimals. Okay, that's perfectly fine. I use fractions. I use fractions for a number of reasons. When I was in the, I don't know, 5th grade or whatever, when we first started learning fractions, I had great difficulty with them. So I went to tutoring. I ended up, and then I ended up in graduate school studying calculus and stuff. And so fractions became second nature to me. So now I use fractions. I use fractions largely. The larger reason is because fractions give you an accurate number. Decimals don't always do that. For example, if you take your calculator, your cell phone's calculator, and divide 1 by 3, 1 divided by 3, your calculator freaks out. Okay, it says 0.3333333 repeating. Okay, whereas as a fraction, that's a perfectly rational, reasonable number. It's 1/3. All right, so 2/7 divided into 7/5, and that gives us 7/5, or divided into 2/7 divided into 2/5 gives us 7/5. All right, and you see that I've then done that through the line. And go ahead and practice doing that. This kind of gives you the answer. You can practice doing that, because there will come a point when you have to determine the elasticity. All right, for reasons that we get into. Okay, for tax implications, for revenue implications. And then over here, I've also calculated the revenue so that you can see our total revenue test. Okay, and revenue is price times quantity. $2 times quantity of 300 gives us $600. $4 times a quantity of 240 units gives us $960, etc. And so you notice here that we go from 1,080 down to 960, and the elasticity between these 2 points is greater than 1. And so the price increase leads to a revenue decrease. The price decrease leads to a revenue increase. That is consistent with what we just talked about with the total revenue test. And that's what I just said. I just said that here. I probably could have held off till we were here, but we'll just repeat it. Okay. So if you look at a price increase from $4 to $6, okay, the revenue increases by $120. That tells you that between $4 and $6, the elasticity is less than 1. In fact, it's 5/7. Okay. Whereas if you move from what we just saw, $6 to $8, we see that the elasticity is greater than 1, and the price increase leads to a revenue decrease. Between $4 and $6, the price increase leads to a revenue increase. So it's less than 1, 5/7, as opposed to 7/5. This matters because, like, for example, if we're a government and we're going to tax a product, where on the line are we taxing it? Okay, if we tax a $4 product, that's at the inelastic point of the line. So the tax is going to lead to a price increase. That's actually going to lead to a revenue increase. That's going to benefit both us and the entrepreneur. But if we do it up here, okay, where it's elastic, if we slap a tax on there, there's actually going to be less money coming in. So it's going to be counterproductive. A few additional points on the price elasticity of demand. The first thing we note is that elasticity is not uniform throughout the line. We saw that in our example. At lower prices, products tend to be more inelastic. In other words, at lower prices, changes in the price create less of a demand shift, create less of a demand change. And so at higher prices, smaller changes in price as a percentage will lead to higher demand changes. Okay, and so like if you look at our example, the price from $2 to $4 has an elasticity of 1/3, but the price of increase from $8 to $10 has an elasticity of 7/5. Okay, at higher prices, lines tend to be more elastic. And the main reason for this is because it's a higher percentage of income. At higher prices, it's a higher percentage of income. And we'll deal with that when we deal with the determinants of demand. But higher percentages of income are much more sensitive to price changes. And then the other thing is whether or not a price increase leads to a revenue increase or not. It depends on where on the demand curve you make the price change. If you change price at the low end of the spectrum, where prices are low, a price increase is typically going to lead to a revenue increase because you're at an inelastic part of the line. But as you move down the line, if you move down the line or up the line, I suppose, in prices, then it becomes much more inelastic. It becomes much more sensitive. This is why actually, I mentioned earlier that typically speaking, demand curves tend to be curvilinear in nature. They tend to be concave. That's why. But at any rate, we'll deal with that. The other thing we want to broach, at least briefly, is the idea of cross elasticity. As we said before, every good is related ultimately to every other good in the market. The strongest relationships are what we talked about with substitute products, where they do the same thing, or complementary products where they work together. But the idea that I got at before was that because of limited resources, I only have a certain amount of money. All right. So if they raise the price of a product of one product, it's going to cause my demand behavior for all products to shift. If I have to pay more at the pump for gas, that leaves me less money to buy potato chips. Okay. And so what we can deal with then is the cross elasticity. The higher the number on cross elasticity, the more related the products are. The lower the number on cross elasticity, the less related they are. And that's because what we're going to do here is we have two products. We have product X and product not X, which we call product Y. Okay, well, a price change in product X is going to lead to a quantity change in product X. We know that. That's the law of demand. It is also going to lead probably to some change in Y. The question is how much of a change in Y. And that depends on the strength of the relationship between the two products. Okay? And so, for example, let's just think through this for a minute. Okay? Product X changes. Let's say product X increases in price, which means the demand for X is going to go down. Okay? If the demand for Y goes up, that means they're substitute products, right? From our definition of substitute products that we dealt with earlier, if the price of X goes down, okay, and the quantity demanded of X goes up, then the quantity demanded of Y will drop. That's a substitute product. So that what you'll end up with now, unlike price elasticity of demand, with cross elasticity, you don't take the absolute value. You can actually end up with negative numbers. Okay, so a price decrease, which is a negative number in X, which will lead to a quantity increase, will lead to a quantity decrease in Y. So a price decrease in X leads to a quantity decrease in Y. That's substitute products. Okay, so if cross elasticity is positive, then they're substitutes. If cross elasticity is negative, then they're complements. Okay? Now, the important thing is that there are implications uh, of a tax implications on price elasticity of demand based on taxing. Okay, and the easiest way is to go through this example here. Okay, so that we can understand this. The point I previously made, whether or not a price increase results in a revenue increase depends on where in the line we have that price increase. If we increase price from $2 to $4, we're actually going to increase revenue. If we increase price from $4 to $6, we increase revenue. But if we increase price from $6 to $8, revenue drops. This is because the line becomes elastic at that point. Okay? So let's suppose that we're at the $4 mark, and the government levies a tax, a 50% tax on food products at local bars, raising the cost of our fish sandwich to $6. Well, with the price increase resulting from the tax, the revenue goes up to $1,080. Revenue goes up. They've put the tax on at an inelastic part of the line, okay, of which the government is going to keep $2 per unit. That's the 50% tax, which is $360. Therefore, the entrepreneur keeps the other $720. All right. Now, you'll note that if the entrepreneur does the tax increase itself or does the price increase itself, it makes all of the money itself. The government doesn't have anything, but because it's a tax, the government's going to reap some of the benefits here. And what you'll notice is that for the entrepreneur, the revenue goes down. Okay. Overall, you're bringing in more money at $1,080, but the government pockets $360 of that in the tax, and so the entrepreneur is left with $720, less than they were getting when the sandwich was $4. Okay, and so what this means is that of this, the entrepreneur pays a certain amount of the tax, and the rest of the tax is passed on to the consumer. All right, and we'll deal with government tax policy a little bit more when we get to macroeconomics. For now, we just want to take a quick look at the tax implications of the price elasticity of demand. Okay. Now, if we look at the second part of this tax implications, okay, let's say now that we start with the price at $6 and the government imposes the 33% tax. That'll bring the price to $8. Well, now you're working with an elastic part of the line, okay, which means that revenue is going to drop. The government is going to get $240 out of it. They're going to get $2 per sandwich for 120 sandwiches. So they make less than they would if they raised the tax at an inelastic part of the line. The entrepreneur will keep 720. Collectively, it'll be 960 in revenue. Okay, 240 of that is going to be paid by both. Basically, the 240 is going to be split. It's going to be split between the consumer and the entrepreneur. Note that the entrepreneur keeps the same revenue whether the tax is levied at a lower or higher price, but the government gets less revenue from the tax at a higher price. This has tremendous implications, actually, because in the state of Pennsylvania, for example, in fact, in most states, in the state of Pennsylvania, okay, the two big ticket tax items are gasoline and cigarettes. All right. Well, at a certain point on the line of any product, it becomes elastic. That's true of inelastic products like gasoline and cigarettes too. At a certain price level, it will become elastic. What the government is interested in doing is raising revenue by taxing this. The vast majority, when you go to the pump and pay $3.10 a gallon or $3 a gallon or $3.25 a gallon, the vast majority of that is taxed to the state of Pennsylvania. That's why gas prices are so dramatically different from one state to another state, okay, is because of the taxes that are levied. Pennsylvania levies a heavy tax on gasoline. Well, if they levy too high a tax on it, which they did, gas a few years back jacked up above 3.5. And what the state realized was they were actually making less revenue because at a certain point, even gasoline becomes elastic. And if you tax it at that point, you're going to end up with less revenue, like they do here. Cigarettes are the same thing. Okay, you've got to be very careful when you tax it where you are on the demand curve. Are you at an inelastic point? or are you at an elastic point? If you're at an elastic point, the increase in tax is actually going to reduce the amount of revenue you generate. And that's kind of where they've gotten with cigarettes, and they're not quite sure where to go with that now. We'll now deal with the determinants of the price elasticity of demand. The first one that we'll deal with is whether it's a necessity or a luxury item. This has to do, I mentioned it earlier, the fungibility of a product. How useful is the product? How much is it used? Okay. And so, like, when we deal with things like gasoline or addictive substances like cigarettes, we could say the same thing with heroin or cocaine or anything else. If it's an addictive substance, it's very inelastic. Addicts are not going to be sensitive to the price change because they have an addiction. Okay. What happens though, like what the state of Pennsylvania, what happened with the state of Pennsylvania from our previous example, when they, now that they're at the higher end of the spectrum price wise for cigarettes, as they tax it, their revenue drops, and what happens is you have an increase in people seeking treatment for cigarette addiction. Okay, trying to give up smoking. The same thing happens with addictive substances. If the drug dealers raise the price of opioids too high, then you're going to have a higher incidence of people going to rehab centers. Okay? And so actually, if you think about it, if you think that through, rehab centers have a vested interest in government taxing or in drug dealers raising the price of their product. But at any rate, we'll move on from there. Okay, so it depends on the fungibility. The less necessary it is, the more elastic it is. Okay. Now here we run into some trouble because the definition of a necessity versus a luxury is very different. Okay, like I'll give you an example. Like some women, my wife told me, she says, I got to go get my nails done. Got to go get your nails done? It's a necessity? No, I think that's a luxury, isn't it? And in reality, in markets, they define the difference between these two things as consumer staples and consumer discretionary. Consumer discretionary is luxury. It tends to be more elastic. Consumer staples tend to be less elastic, more inelastic, and so they survive economic downturns a little bit better in the market. Okay. The second determinant is substitute products. Greater the availability of substitutes, the higher the elasticity will be. Okay? And so, for example, automobiles are highly elastic products. Okay? Because you have any number of competitors within a particular class. Just recently, I went and investigated the small pickup truck class. I ended up with the best truck I've ever had, a Nissan Frontier. But I investigated Chevy Colorados. I investigated GMC Canyons. I investigated Honda Ridgelines. I investigated a whole bunch. Well, price has something to do with that. And one of the funnest things, if you've not done this, if you've never gone car shopping and you go car shopping, University Boulevard is car shopping central. It is the greatest place on earth for shopping for a car because every car that's produced on the planet is available on that stretch of road running up the hill to Robert Morris. And literally, you can go door to door. In fact, we did that when we bought the last car. The last one that I totaled was a Chevy Cruze, which we bought over at North Star. The day we went to buy it, we went to 7 dealerships. We went door to door. Okay, and we put these people directly in competition with one another. All right. These guys are willing to do this for me. They're willing to give me free oil changes, free inspections. They're willing to cut their price down. They're willing to give me money back. They're willing to give me rebates. What are you willing to do for me? This is brilliant. You put them directly in competition. Okay. You can do that because you have enormous amounts of substitute products. Okay. But in other markets, you don't have substitute products. All right. You don't have as many substitute products. I'll give you another example. We could have examples all day on this. Some years back, maybe 15 years ago, the state of Pennsylvania opened up to competition something that used to be a natural monopoly, which we'll deal with when we get to imperfect markets. Don't worry about it now. But they opened up utilities, particularly electricity, to competition. Well, that made the electric market much more competitive. Okay, you can now shop around for your electricity producer. All right. And so if one guy's going to charge you 8.5 cents a kilowatt hour, you can go and say, look, I got these guys over here. They're willing to go 7.5 cents. Can you match them? And so it's great fun to deal with that. That's when fun is in the market. However, there are also inelastic things. When you have no choice, then it's inelastic. This is one of the problems with monopolies. They tend to have an artificially low elasticity for their product. Okay. And like one of the things I'm dealing with right now that's going through me like a rusty steel nail. I live in Rochester Township. When we moved in here, the sewer people over here, they charged $11 a month and they charged me every 3 months. So I got a bill for 33 bucks. Then they upped that to 13. Then they upped that to 19 a month and started sending out a monthly bill. Now they charge 19 a month, and every 3 months they top another 40 bucks on that. The problem is there's nothing I can do about that. If I want water in my house, I have to use their sewer lines. They have an almost purely inelastic product. Okay, they could charge me $1,000 a month, and I have no choice if I want water in my house. My choice would be to dig a well and tell them to go pound salt. Okay. Now, the other one that we talked about is the percentage of income. The percentage of income is one of the higher determinants. The higher the percentage of income, the more elastic the product. This is another reason, for example, that automobiles tend to be very highly elastic because they're a high percentage of income. Houses are the same way. They're a high percentage of income. There are any number of houses available on the market. Okay, so you can get into haggling games. The higher the percentage of income, the more you can haggle with the producer or the salesman. Okay, you can bring it down. The lower the percentage of income, the lower the elasticity will be. And I think that concludes the PowerPoint on demand behavior. The next thing we're going to be looking at is the supply behavior, the behavior of producers.